Okay, so we're going to start instruction today with session 18. I had a lot of you guys say on the surveys, those of you who've responded, that you just do better with interactive classes. Believe me when I tell you, I wish we could do that instead. This is not a class I would ever choose to put online if there was a choice. However, I know we're all doing the best we can. Okay, so what I want you to do is if there's ever a question or there's something that you just need to talk about more, feel free to email me. If it's something that we can't resolve in email, I'm happy to set up an individual Zoom session with you. Obviously, I can't do that all the time, every time for every single question. But if it's a particular thing that you need to talk through, please email me and we will set that up. I don't want you to think that I would ever be mad for you to tell me that something isn't working and that you need something else. It's impossible for me to know that if you don't tell me. So please, please do so. This is just a situation that's sort of unprecedented. So we kind of have to work with what we have to work with. And I realize that that requires a lot of trust on both sides, but please do understand that I will be taking that into consideration in terms of how I score things throughout the rest of the term. Okay, so I hope that that puts your mind a little bit at ease. So let's look at session 18. Okay. This is one of the lessons I really wish we were teaching face to face because statistics is sort of one of my favorite things to teach. So, when you're looking at these graphs here, these are just two graphs that I just sort of made up. Okay, that data didn't come from anywhere other than the idea that brand Y and brand Z raisins, if you went back to session 17, we did have a prompt where it showed us if we took a particular brand of little mini boxes of raisins, we opened them up and we counted how many raisins were in each box. We had sort of a bar chart that calculated for us how many boxes we found a certain number of raisins in. So it asked us to draw two very different bar graphs here, and it says to put at least 25 raisins per box in. Both have a minimum of 25. Okay, so that's why our x-axis here only goes down to 25 because that's the smallest number of raisins we would find in a box. And we wanted to test at least 15 boxes of raisins. How would I know that? Okay, then I'm going to look at the number of boxes I have in each count category. Okay, obviously I have more than 25 here. So for right now, I want you to ignore these numbers underneath the bars. That's for a later question. But if we start looking at just the first question that it asks us, again, I just made these up. If we were doing this in class, I might ask everyone to make up their own bar graphs for Y and Z, and then we might share them and talk about them. We can't do that. So we're really just going to have to talk about mine. If I look at brand Y, this is a perfect example of a symmetric unimodal graph. Okay. Now, what do I mean by unimodal? I see that 28 obviously happened the most. None of the other peaks are as high as 28. So that tells me 28 is the mode here. It's the most frequent result because its bar is the highest. In terms of it being symmetric, if I were to pretend that I drew a line straight down the middle here, I would see that this cuts this pretty equally in half. So this is, if anything, this looks very normal in statistics. So if we were to draw like a little curve over that, we would see what kind of looks like a good bell curve there. However, if I look at Z, obviously this one looks much different. It is unimodal. Okay, we have one highest peak here, which is at 31. It tells me that most frequently the boxes had 31 raisins in them. But it's not a symmetric graph. In fact, it's what we would call left skew. Okay, because if we were to draw a little curve that just sort of touched the top of all of these, okay, we would see that peak here, but we're going to have kind of a tail that tails off here. So we have a little bit of skew here. We expect the majority of the boxes are going to have these higher number of raisins. Very few are going to have these lower number of raisins. Okay, so that's what my description comes from here. Brand Y, very symmetric unimodal. Brand Z, not symmetric, left skew. Okay, so I'm going to scroll down a little bit. It said, what value did you choose in the previous session for the typical number of raisins in a box? If you went back to page 119 in our last session, 28 was where the peak was, very similar to what we saw in brand Y. So that's why we chose it as the most typical number of raisins. It gives us a set of data here. Okay, some raisin data. In other words, this doesn't match either one of these. This is just some data that they came up with as a prompt, and it didn't put them in order. They just chose, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes of raisins and counted how many raisins were in each one. So the first thing it asks us to do is put this in order. Okay, so that's what I did down here in the red. Notice I mark these off when I'm trying to put them in order. Because if you're anything like me, sometimes you miss one, you skip one, you forget one, and that will cause your data to be off when you start doing analysis. So as I write them down, I try to mark them out, and sometimes that helps me find if I miss one. Okay, so I put it in order. And the next thing it asked me to do, and that's what I've done in pencil here, is cross out the highest and lowest numbers on the list and continue crossing out pairs until one remains. So usually what I do, sometimes I tell students to take their fingers because especially if you have students with special needs, it's hard for them sometimes to remember if they've crossed them out in pairs because they actually have to pick the pencil up and they can't remember if they've marked off a high or a low. So sometimes I tell them to take their fingers and cover up the numbers on the outside and move towards the center one at a time. Makes that a little more kinetic movement for them. It also makes it a little more visual and keeps them from forgetting to mark them out in pairs, which for very young kids and sometimes our students who have some unique learning needs, that's something that will help. Okay, have them put their fingers here, the right finger here, the left finger here, and then move them towards the center one number at a time. That will help if marking them out is something they can't do. For you guys, you're perfectly capable of marking them out. What I start doing is I just say to myself, because I'll be the first to admit I have horrible ADHD, and even I can get lost if it's a big set of numbers. So I repeatedly say to myself, high, low, high, low, high, low. And that keeps me in track of marking them off in pairs until I get to the center. So as you can see, okay, I get to the center of 28. So this number is the median, okay? What data element in the ordered data was that median? So it wants us to count, okay? What number of data was this if we put them in line? So 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th element. It asks how many boxes were below. Okay, so if this is the 8th, we know 7 are below. We've already counted those 7. And how many are above? 1, 2, 3, 4, 5, 6, 7. Okay, so that's kind of the purpose of a median. That's why it makes us think of the word middle. If you're directly in the center, if your data point who's directly in the middle, there should be as many below you as there is above you. Okay, so 7 above, 7 below. Sometimes you also hear that called the 50th percentile. As this class goes on, we'll be talking a lot about percentiles. It's probably not something you're going to see on your praxis exam. However, it is something that once you get in a classroom and you start trying to interpret student test results, it's going to be something that you want to see and you need to understand. Okay, so we'll talk about that in the future. All right, let's keep going here. It asks us to copy this same data again, but leave out the 31. Okay, so instead of 15 data points, now I'm going to have 14. Okay, now I want you to think about where my 15 came from. I had 7 below, I had 7 above, that's 14, plus the one in the center, that was 15. Okay, so now I'm going to get rid of this 31 and I'm going to recopy that data. So I'm going to scroll down. Okay, and that's exactly what I did here. Recopied it exactly the same, left off the 31. And then it asks us to find the median again. Okay, so I started again, high, low, high, low, high, low. The problem was now because I don't have 15 data points, I have 14, I'm not going to have a single number left over in the middle. I'm going to kind of end up with 2. Okay, since there's not a one singular digit in the middle, we still have to find the center of the data. You can't say 27 and 28. That's not the center. The true center is going to split this directly in half. Okay, so I have teachers sometimes who tell students average them. Yes, you certainly can do that. But also, in the case like this, common sense is going to work. I could add 27, 28, and then divide by 2. But if I'm looking for the direct center between 27 and 28, it should be obvious to you that that's 27 and a half. What that means is that the median does not have to be an actual result that's included. There were no boxes of raisins that had 27 and a half raisins. However, 27 and a half is the median of this data because it is exactly what splits it in the center. Okay, so that is where my median is. That means this 27 counts as part of the lower half, and this 28 counts as part of the upper half. Okay, the median is that 27 and a half.